Hello, hello. I hope I'm audible. Hello, hello. I hope I'm audible. Okay, so it's a little late stream, but we are live, and we will not solve atcoder problem today. We will be solving some remaining problem, or specifically one remaining problem from you know CSES. So I think maybe we'll do it here. Okay. Okay, we'll do it here. This is the problem. Counting numbers. Okay, so our task is to count the number of integers between a and b where no two adjacent digits are the same. So we are given two numbers a and b, and we need to count numbers in such that their digits are not adjacent the same, no adjacent digits are same. So basically this number or this number or this number, these are not allowed. This type of numbers are not allowed. We cannot have adjacent digits to be same. Okay, so we can have this, we can have this, and we can also not have this. Okay, so we need to count these types of numbers and return that count. Okay, so before we proceed, the thing is we need to simplify this problem a little. Okay, so instead of thinking of like solving the problem between these ranges, we can do one thing. We can do, we can count all the numbers till a. So like for these types of number where the adjacent are not same, and we can count all the, we can count all the numbers like that till b. Okay, and suppose this is m, this is n, then our answer will simply be m minus n, n minus m. Okay, this will be our answer. So what we need to focus on is basically a function which accepts a number and then returns the answer for all the numbers, or not answer but returns count for all such numbers till x. Okay, so this is a digit DB problem because the limits are of the 10 to the power 18 rate, so we cannot just simply do a linear search, linear loop or something. Cannot do, so we have to do digit DP. So for the states, we have solved one digit DP question, and I'm actually learning about digit DP. So the thing is, most of the problems in digit DP have a similar type of template. Okay, so the states are like same for most of the problems. They will have a position. Okay, a position will be there. You will have a tightness. Okay, you will also have whether we also have a previous digit, and in this problem specifically we will have a leading zero. Okay, since since we will be building in these 18 blocks, right? Our number we will build in these 18 blocks. For the 10 to the power 18. Okay, we will be building in this. So if we start from 0, then most of the digit here will be 0 only. Okay, and that also counts as adjacent digit being same, right? So for that we have a flag called leading 0. So if it is set to 1, that means we are not going to check for the adjacency condition, otherwise we will check. Okay, so if it is set to 1, that means leading 0 is there. Okay, let me do it like this. Our position will go from 1 to basically 20. To 18 or 19 basically, but for I think 19 and 20 would work. Okay, but I think we should have an 18. Should be having 18. Okay. We'll go till 18. Or maybe this will depend. This will depend on the number. Okay, this will depend on the number. And we have tightness. So tightness basically tells us whether the prefix for the current position in the number or the limit we have been given and the prefix of the number that we have built, are they matching or not. So basically if we are given suppose x is like 1 2 3 4 5 type thing. Okay, and till 3 we have built a number that is like 1 to 2. Okay, so in this case tight will be 0. Why? Because the prefix or for this position, right? For this position, for this position tight will be 1. Why? Because if we look at the prefix, they are matching, right? So here the limit of basically the digit limit that you can put here is going to be limited, so we can only put 0, 1, 2 and 3. Otherwise, if it had been like if it was not tight, if it was tight was 0, that means that we are not we are not matching the prefix, and that means that the number we are building is less than the given number. So we could have like put 0 to 9 here. So tied will give the limit on what digit we can put. Okay, and previous digit is basically 2 here. So here for this guy, this position, previous digit will be 2. So basically previous digit. Why we need this? We need to check, right? The adjacent digits are not same. That's why. And again, leading 0. Leading 0 is see, if you have a situation like this, so let's say this, these are all leading zeros, right? We don't want to count those as like we don't want to not consider it. Wow, what English. So anyway, we still need to consider them, okay, because these are leading zeros. So this is equivalent to 23 only. 23 is a valid number. So we are building from left to right, right? So we need to have a flag to inform other states of whether the zeros are leading zeros or whatever. No, whether we have started building the number or not. Okay, so we need leading zeros for that. Again, okay, so we have the state, we need base condition. We need base condition. Okay, what if we have reached the suppose if there are n numbers, n digits in a number, and by traversing or by DFS, maybe DP, we have reached the last digit, not last digit, but rather we have reached the last digit plus 1. So if we start from 0, n minus 1, we have reached n. In that case, that means we have successfully made a number. So we will just return 1. So basically dp, so if position is double equal to n, in that case we'll return 1. Okay, in that case we will return 1. Okay. Base case is done. We need transition. Okay, so transition, how will it work? So basically, if we are at if we are here, right, this is the first position here. Suppose we chose 0 here, that means it is leading 0. So again we go to the next position, and in that next position we can again choose 0, that will also lead to leading 0. We can choose 1. In that case leading 0 will not be 1 now, it will be 0. So leading 0 will be now 0. We have previous digit now as for the next one as 1. Okay, previous digit is now as 1, and also tightness of this will be determined by the digit. So if this is the digit, then basic so of course it is not tight, so it will be 0, and in that case position will be 0, 1 and 2. So this will be the next state. Okay, so basically we need to calculate what position will be position plus 1. We need to calculate the tightness. Okay, and tightness will be given by whether the prefix is tight and the digit we have currently used, okay, is it equal to the max limit that we can do. So if it is tight, then the limit that you can so the number limit will be, of course it is equal to this only, so we can only put 0 to 3. Okay, if the prefix is tight, otherwise we can go 0 to 9. Okay, okay, this is the tightness, next tight. Okay, and we have the next leading 0. I'm calling it LZ. So leading 0 will be whether we have a leading 0 and we have a leading 0 and also the current digit that we have used is also 0. If that is not the case, that means we have started number. Okay, so these two are calculated. Third is previous digit. So for this, okay, for this thing we have to consider for when we have a leading 0. Okay, what should we pass? So 0 to 9 we cannot pass, 10 we can pass. So what we'll do is, if this next leading 0 is there, then the next previous number will be 10. Otherwise this next previous number will be the digit we have used only. Okay, why is that? Because if it is 10, that means the leading 0 is there, and we will not process that, and we will not check the condition. Okay, and how will we set the current DP state? So the current DP state, okay, so basically it means position, and not like this, basically position, tight, and your previous and your leading 0. We will add into this all of the possible answers from putting different numbers. So basically we will run a loop from the we will run a loop from the we'll run a loop till what? Our limit. Okay, and we'll do this. We'll go to the next position. We will go to the next position. We will check for the next tight. We will check for the next previous, which is nothing but the current D only. We will check, and we have the next leading 0. We will calculate all this, we will modulo this, and in the end we will just return the answer, which is this only. Okay, base condition is done, state done, transition done, answer. Answer is simply dp. We will start from 0. We will have the prefix previous digit as, we will have tight as 1. We will have previous digits at 10 and leading 0 as 1. Okay. For number A, so we need to convert number A into array. Okay, so for, well, let's see, we'll write here for A as array. Okay, and okay, and we have dp 0 1 10 1 for B as array. So we calculated for B and then subtracted A to it. So this will be the answer. Let's try to implement this. Okay, let me contain this in a square. Okay, let's go. We don't need anything else, or do we? Okay, let's go with our template only. So this is our template. We have two numbers. Okay, we'll make a function. Okay, and here we'll return should we do a DFS or should we go for, because this is a for it's better if you go for a DFS. I don't want to write 4 loops. Yeah, so we'll write a DFS. Okay, so basically we'll go for 0 and 1 and 10 and leading zeros, yes. So this will be okay. Now we need to write DFS. Before that, we'll convert x into array. Okay. We'll convert x into array, and for that we will have it's a digit only, right? So it will not go beyond integer limits. Anyway, it should not even be, I should not even use integer for that. But let's see, we have integer of digits. I'm not doing this, so digits will be I'll do this while x, I'm going to divide x. Okay, so instead of this while loop, right, it's a side of int temp is equal to x, temp multiplies equal to 10, and we'll have digits dot pushback temp. Okay, done, and then we'll reverse digit, and we are done. We will write the DFS here. So we have position, we have tightness, we have previous digit, and we have what? Leading zero. Okay, so if position is double equal to digits dot size, then we will return 1. We'll also have a DP here. Four states. So our number will be of 8. This array, digits array, can be 20 size only, right? Max it will be 18 size, but we are having some so that there is no offset errors for 20. Okay. Tightness will be 2 only. Previous, it can be up to 10, so 11. Leading zero will be boolean only, and we'll do a mean set here. Mean set on DP with -1 size of DP. Okay. Again, if so the thing is, I've seen a very cool trick of doing this. Instead of doing all this, what people do is they have a pointer to it. Okay, basically reference to it, and then they check whether the answer is has been calculated or not. So they do this. Otherwise, what they do it like this, and in between I will do our calculation. So limit will be, if it is tight, in that case this, otherwise this. We have calculated the limit. We will run a loop from loop from 0 to limit, and we will calculate tightness first. So it will be based on whether the last thing was tight and the digit we have used is equal to limit or not. Okay, and we also have leading zeros, so we can do it like this. Next, leading zero. So it will be we have a leading zero and the digit we have used is 0. Then only. Then if there is a leading zero, we will do next previous. So if there is a leading zero, in that case the next previous will be ten, because we don't want zero to 9 in that. Okay, else it will be the digit we are using only, and we'll do this answer plus equal to DFS position plus 1, next tight, next previous, next leading 0, and we are done. But before that, see, if there are leading zeros, okay, in that case if there are not leading zeros, and if there are not any leading zeros, okay, in that case if the current digit is equal to the previous one, so we don't do anything. We don't want to include this, so we'll continue. Okay, this should be enough. Okay, and the answer will finally be count till B minus count till A. Will put the answer here. Okay, string 30.cpp. Sorry, C. Okay, sorry. All X, not all X, just digits. Fuck. Okay, yeah. Otherwise answer is 0. Need what? answer is negative for some reason. Why? Why am I getting negative numbers? Is this thing correct? Three, two, one, 3, 2, 1. Okay. Got it. So we need to clear it. Digits dot clear, because we're using a global thing, right? Okay. One thing is missing now. Damn. We have one missing. Okay. We need to include A also, right? Inclusive. So we'll calculate till a minus 1 and we'll subtract that because we need a also. Okay. So I think this should work. Okay, we not copy. We submit like this. 30 TLE MLE. Wrong answer. Damn. Wow. So this is a problem for tomorrow. And actually I'm very tired. I was playing PUBG all night with my friends yesterday. So I have not slept properly and I want to sleep, but it is not the time. Okay. So that is it for the stream, and I hope that you guys had fun, maybe. Anyway, how many of you are watching? I don't think that 0. So there is no one watching right now. I mean, maybe in future someone will watch. So it is kind of like a video for myself. But if anyone does watch this in future. Also, I am doing this to improve my vocabulary and English. Okay, so I have a lot of things going on in my mind. I think everything in English, even though I'm from a Hindi medium school. but when it comes to talking, or giving or like expressing my thoughts in English while speaking, so just doesn't come out. Also, so that is also one of the main reasons I'm doing this. Okay, so let's see, we'll improve slowly in both the fields, in programming plus English, and by the end of this year, right? Let's see how much we can improve. Okay. Uh, yeah, that is it for the stream, and I wish you all a very good night, and yep.